Okay. Uh, Looks like we're live, which is good. So this is just gonna be a live stream where I model. Uh, so yeah. So I'm gonna make sure the stream is running well. It looks pretty good. So yeah, what's up, guys? So initially, I was gonna show a what's it called a sketch of the hand that I drew, but I kind of lost it. So it was on like a napkin, right? But I'll actually create a quick sketch right now, so you guys can kind of see what the idea is. Uh, so the V2, which I have right here, I noticed a really interesting phenomenon, right? So when you bend the finger, if the top servo, this servo right here, if this is bent, if it isn't out all the way, it tends to bend the finger along, right? And this finger is not rigid; it actually like moves like that. And then I was thinking, well, this one uses how many servos? Like 1, 2, 3 plus 8, so 11 servos. No, that's actually 12 servos because of the thumb servo. So 12 servos for one hand is like absolutely insane. I mean, holy fuck, 12 servos for one hand. And then I was thinking like, oh wait, if we do that, why don't we use just 4 servos, right? And the thing is, like, this thing isn't very strong either. So I was thinking we can make it so it's like leveled, right? It scales. You can put in different servos to get different amounts of power, which that's awesome. And then we could use these servos as 4.5, or the bigger ones as 7.5 kilograms for that much torque in each finger. And then we could have it where it's just one finger that drives the bottom, the what is it called, proximal phalange, right? If it drives the proximal phalange, the other two phalangeal joints would just curl as the bottom one curls, like how you would do this motion, right? And so if we have it where, here, I'll actually draw a sketch right now, so you guys can kind of visualize it. So, say you have a servo right here, right? Like that. Okay? And let's say the servo has a linkage connected to a joint right here, where the joint also has a linkage to it, right? Like that. So this is the joint here, and then that's the servo. And then if the servo is connected to that, when it pulls along the bar, it would, you know, it would when it pulls along the bar, it would do this, right? When the bottom one is pulled, I was thinking we could have a string on the bottom, which is connected to the back of the hand, where when you would pull it, it would retract, it would loosen the string, which in turn would allow the fingers to retract. And when you turn it, it would open up, where it would open up, and then the top part, you would pull it, and when you open it, since it's a rigid bar, it would push it away, and the bottom would also pull it. So let's just start modeling now. So I have the V1 finger here, the V1 finger, this one. So this could be a pretty good reference, because this is a pretty good size for, it's proportional, I guess, kind of proportional to a human hand. My hands aren't like very giant, or like, yeah, it's not super big. So I guess compared to V2, it's pretty small. Like V2, even compared to this, it's still like giant. I mean, holy. And I would also want somehow V3 to be controlled, because for V2 to make some sort of control glove, um, it would take it'd be very expensive, and also it would be very complex. So for V3, since it's just a four servo for since it's just one servo for each finger, excluding the thumb, it would actually be pretty easy to make one just using flex sensors, right? So I have the model pulled up here. These are just the old, you know, other hands. It's like V2, V1. I really kind of made the design. So this is the design. Call these the hub caps, and then this is um, the bar right here. And there's our two little ball bearings. Uh, I'm gonna only use these big ball bearings for the initial metacarpal proximal phalangeal joint, because if you these are kind of the same diameter as the V2 joint bearings. So I would want to use the smaller ones, like that of a Dex hand, right? Because the Dex hand by the dude Robot Studio, um, he uses like a very clever system where he actually has I think elastic wire in between his finger joints. He kind of weaves it around so that the finger joints are, I guess, connected together in motion, and it's actually pretty hard to pull them apart. Like those are really really strong. And I've also seen he has the ball bearings, the small ones on the joints, right? So I want to do that, but my main focus right now is just finish the bar linkage as well as the phalangeal joint. So yeah, I'm gonna start working. I actually made a little prototype here for this. This is just the joint prototype. These are bearings that I ripped off of my printer, which that's okay because I already had a placement for them, so I just ripped these off. These are thin bearings. So if you compare it to the V2 bearings, they're actually about the same, except that these ones have the, what do you say? They have an extra kind of thing at the top that moves it. That no no that doesn't, that keeps it from moving. So I actually got this off the printer assembly. I think it was the X-axis belt tensioner. It was like this. Like it was the X-axis belt tensioner where it had these two. It had the two bearings, right? And then the two bearings were like this, and they were put on like this, and then the belt would go right here. The I forgot what those belts were called. I'm pretty sure they're called I think the G2 timing belt. I think that's what they're called. I remember using one for an e-bike. Yeah. Okay. So keep getting distracted, dude. Let's work on it. Let's go. So we got a joint right here. I'm thinking for this one, I wouldn't want to keep using those little screws. I'll probably want to do heat inserts, right? But for now, I'll just make like two insert holes right here. Since this is kind of just disposable prototype kind of thing. I'll put a 2.5. Nah, okay, 2 is always good, right? Okay, so you would Okay, so I'll just make 2 screw holes here for now. I'll actually make one here, and I'll make this one where it's a double, so it has more, I guess, more strength. Yeah, I'll do that. This is how many? Okay, so this is 3.73, which that's kind of a weird number. I don't really like that, but that's actually the how big this part is. Right, yeah, this is 3.73. If that's 73, 3.73, it's, I probably want this to be 4, just so that it's actually an even number. So if you go ahead and if I could find my calculator. Okay, so I'll calculate this. This is gonna be 4 minus 3.73. 4 minus 3.73 divided by 2. So it'll go 0.135 on both sides. So 0.135. Crap. Looks like this is attached to that. So okay. Now I think that should be a 4. 4, 4, 4. 1, 2. What the hell? Okay. Okay, now it's 4. That's good. So, let's see the width of this, because you wouldn't want the finger to be very wide. This is 16 millimeters. So with the caliper, 16 is okay. 16 I think is pretty good for, since this is just the what is it called? The first phalange, the proximal phalange, and the length of this is 26.197. So I'm gonna subtract this by 197. Let's do that. Okay, so it's 26, and if we measure 26 out, that's pretty good. Okay. Okay, so let's make the phalangeal joint. I'm gonna construct an offset here, right? And then let's create one where it has all 3 of the screw holes. And then should be kind of form fitting right here. And now on the top, I think it should just be the same as that, right? I think so. I think that's it. Yep. So let's get these 2, I don't know, 6. And then we'll move this down. That. Let's give this a different color, because let's give it like blue. Yeah, yellow and blue. That looks, and it doesn't really look that cool. Let's give this a different color, 'cause it's kind of too. It's just the default gray, and default gray looks kind of bad. I don't really like it. Okay, yeah, that's good. Is there metal? Let's get some metal out here. Aluminum polished. That's aluminum polished. Chrome, yeah, I want a chrome on that. It's about time I chrome the fuck up. Yeah. Wait, this is low-key just cybernetics if you think about it. But usually the thing with those kinds of things is there's a few problems with that. First of all, infections, because since the skin on the outside isn't fully fused with the metal, because I don't think skin can fuse with metal unless you have something like it's like skin seal, which that doesn't exist because it's something I thought of in my head. But unless you have something like that, you're gonna get infections, and you're probably gonna lose more parts than you got replaced. And another thing is, it's looking not reliable because if you don't have a hand, how are you gonna control a hand? Right? You can't wear a control glove because you don't have a hand, and voice activation is kind of weird, clunky. I guess voice activation could work, but like sensors in the actual muscle fibers itself could work. On do amputees, can they still flex their muscles if the muscle doesn't have anything connected to it? Like, I'm guessing it sends signals, right? If you could if you pick up the electrical signals, you could probably make it so they can control it just with their muscles, thought, right? Or you could just get one of those Neuralink BCIs, because I saw in the video they connected to a Tesla Optimus arm, and the dude was like flicking off the camera using his brain. It's pretty cool. I think something like Kiroshi optics would become a possibility in the future, because if they have the Neuralink BCI, Elon said that he was able to get a person who was like blind, and he got the blind person to see using like a little camera, and I think the resolution was like 9 pixels by 9 pixels, which, I mean, that's still pretty good. I mean, if I was blind and I saw 9 pixels for the first time, I would be like, oh my god. But thankfully, I'm not blind. Okay, so this actually looks pretty good. I should probably be closing off these holes, honestly. I don't think there is really a use for these. Actually, no. I'm gonna measure how deep this is. So if we're just going from here to here, that's 10 millimeters. So a centimeter deep. That's actually pretty good. I'll leave it at that. Should I seal these off? Yeah, right? Yeah, I should. Okay, so if I go here, I'm gonna seal off the top ones. I think I'll keep the bottom one so you can have a screw and a bolt and a nut. So let's seal these off. So since it's actually 10, I'll raise this by 1, and then I'll get and then I'll have the actual joint mechanism on this array here. Yeah, that's perfect. So let's measure this. From this end to that end is how many? 16. Okay, so 16. So this is 3. Okay, so each is 1 centimeter. 1 millimeter. Okay, so 16 millimeters. 10 millimeters. And then from here, from where I just created that point, I could go a 2 millimeter here. Is that equal? No, it's not. I don't think it is. Is it? Yeah, no, it's equal. Okay, so these 2 millimeters can go up. Actually, I'll remove this planar level. No, that's good. Okay, so this one goes up 5. It kind of looks weird, if I'm honest. But that's 16, which 16 high. That's actually not bad. It's not bad. I wonder how strong this joint will be. Maybe I should make it a an insert joint, because I don't think it'll be very strong just like this, right? Since if it's printing up, the print layers will be like that. So an insert joint would actually be really good for this. But for now, I'll just keep it like that. So let's get the center point of this. Yeah, I don't know. I'll just make a 2mm hole. Okay. Let's get these trimmed off. And I'll make like a 2mm is awfully small. Actually, no. Let's check how big the metal inserts are. So let me get the metal inserts. Okay, so I got my joint rod right here. This is just a rod I ripped off a like RC car. So if you measure this joint rod, this is around 2.5 millimeters in diameter. So let's do 2.5 here. 2.5. Come on. Nope. How is that lagging? And RTX 3060 2.5. Oh my lord, that is giant. I look so small in real life, but then I in the in the CAD, I look at it, I'm like, holy, that thing is giant. Oh my lord. Okay, so now let's just get a representation of the metal insert here. So let's get a 2.5 rod. 2.5 rod, yeah. And yeah, no, it's good. So the end from here to here is 10. Okay, let's get this as 10. There you go. And let's just make this chrome, since it's metal. And metal is chrome. So like chrome from Cyberpunk. I'm chipping in. Alright. So the metal insert goes in just like that. Metal insert or joint rod? I'm not sure. Okay. That looks kind of good. I'm gonna be honest, that looks pretty good. Let's get a let's get this as an insert joint. Let's get a cavity here. So yeah, okay. I know what to do. I know what to do. We will do a cut. We'll do a cut. We're gonna cut this. Split body. We're gonna split this right here. Boom. Split. Split this right here. Bam. And we're gonna split this right here. Boom. And we're gonna split this again. We're gonna split it. Right here. We're gonna split this body. Bam, look what we got here. Boom, we got the insert joint, but we're gonna fix these screw holes here actually. Although the insert joint is good, the screw holes are kind of messing it up, so why did I say insert joint? I don't think it is insert joint. It's a insert. No, it is a joint because it does have the metal rod like rod reads from AOT. Okay, so the metal insert is here, and we'll get this out, which that looks pretty good. Although I am a little confused as to how I would do this. Should we insert the insert with another rod, or should we just screw this thing in? We could do it. We could do a screw from two sides, right? Or we could put an insert, but we already used the insert, and I kind of have a limited amount of these. I mean, yeah, I have enough for maybe five, six joints really. I think I have a few more, but I think we should just use a screw on both sides, right? So let's actually do that. Well, hold on. You would want this to be rigid, so I think we should actually extend this a little bit with this. Well, no, that's okay, because we can do a okay, wait, so printability, right? You want to be able to print this. Yeah, no, this is good. This is good. So what we'll do is we'll actually get a we'll separate it here. That's what we'll do. We're gonna split this right here and right here. So then we would have two separate joints actually that somehow have holes in them, but that's okay. It's weird, but that's okay, because I can fix it. This is 2 and this is 2. Will extruding this join them together? I hope not. Okay, so I'm joining them like that. There's still separate bodies, right? Okay. Yeah, okay. So since it's like this, what we can do is we can actually extend this around, I don't know. Oh wait. We should split it here, okay? We're gonna split, not this. We're gonna, what the hell? Okay, so we're gonna split this, which, okay. Split this, and looks like that, and this. Okay, so we're gonna split it right here. Bam. Oh my god. What the heck? They just deleted my thing. Whatever. Okay. So we're gonna split this right here. Yes. Perfect. And we're gonna extrude this back 1. We're gonna extrude the other one back -1. Perfect. Now what we're gonna do is we're gonna remove the rod, get this part, and then we'll put a circle here. Alright, extrude all of this. 1. This and this as well. Extrude it 1. Bam. Perfect. Look at that. And then you can put in the rod, put it on both sides, and then slide it in, and you can just Screw it. Screw it. Yeah, yeah. You not. I don't mean screw it as in like screw. I mean screw it as in screw. Put a screw in to hold it in place. Okay. So now extrude it 1. Yes. Perfect. And then we, bam. Look at that. I think I might be cooking here. And then this will have to go like that. Yes. Now we have the metal rod joints, which I'm actually gonna extrude these a little bit downwards because this the cavity here. This is actually okay. I just want to split this here, and I split the other one right here. Nope. Yeah, I split the other one right here and right here. Bam. And then I create a cavity here so that the connection bar can actually, yeah, so that the connection bar can actually move without touching this, because you would also want that to be pretty thick as well. For now, I think I'll just print it, but in later iterations, iterations, I will actually that looks pretty good to me. Let's actually measure the spacing between this. So from here to here is 2.25 millimeters. That's actually very small. It's not good. See, this is the thing with like CADing. It looks very small. No, it looks very big when you look at it. But then you you take the measurements and you're like, holy crap, it's so small. It is so small, dude. What the? Okay, so that's actually not good because the actual diameter of the insert ring, I was thinking it should be like 5. Nah, 6. So you would want it to be 6. If we measure this, the ring, instead of measuring, we can actually just make a ring here, like an actual ring, so we can just see. I don't really want to. Seeing is always better than measuring, because seeing gives you an actual visual representation, which that's really good. That's actually perfect. That's I don't. Yeah, no, it's good. See, if I had measured this, I would have been like, oh, you gotta carve some of this out. Like, nah, we're good. Nah. All right, let's fuse all these together. Right? Yes. Fuse that. Fuse that. Perfect. And then this is still not fused, right? Yes. Okay. Yeah, let's get 2 screw holes here. If we take these 2 midpoints, get the midpoint of that. Wait, why did I pick up my cup and I was gonna pretend? I wasn't pretending. I was actually gonna drink and I kind of forgot about drinking because I was just so focused on the CAD. Okay. Anyways. So we're gonna go down, and then if we take how long this is, I'm guessing this is gonna be this is like 2.7, I think. I don't remember because this is 5, but that's not actually the point. Or whatever. So this is 9. Okay, no, just make a normal 9. Nope, 9.5. I think 9.5 is actually the midpoint of the circle. Yes, it is. So this is a 5. So from the midpoint of the circle, this is 9. So we're gonna go 9.5, 4.75. That would be the middle. Or no? go down from here. 4.75. That is the middle. Okay, so the middle is actually here, but I don't like the placement of that. I'll do the middle of from this point. So this is 7. So we're gonna do 4.5. No, that's not. It's 3.5. Okay, so 3.5 is actually the 3.5 is the midpoint. So from the midpoint we will go. What's the diameter of an M2 screw? Like, we'll just put 2 for now. 2 will be the value, because that's the value that I always use when I create screw holes. I hate saying that. Why does it sound so weird when I say that? When I create screw insert joints. No, it's not insert. It's not. It is not an insert joint. An insert. Okay. Screw. When I create when I create cavities, okay, like cavities in your tooth, like that. Okay, perfect. So, let's get this. All right, so this is good. This is good. Perfect. Okay, so you get the steel and it's not the steel. Is it in steel? The metal insert. In like that. I'm gonna save this. I'll be back with you guys in just a moment. Hey guys, I'm back and I am ready. I'm energized to create. Alright, so we got this. We got so we got this, and then this thumb keeps touching my screen. This thing, it's just touching my screen, man. Okay, whatever. Alright, so we have this. We have the screw insert holes. We have the bottom. So actually, instead of doing the two like this, why don't we just put more along a path? So that's what 20. What? 26.002. This is unacceptable. Okay, I think it's good. What? Okay, so it's 0.01. 0.01. No, it's 0.001. What? How does that? Okay, whatever. It's a very small difference and it probably won't even show up in the print. Okay, so anyways, as I was saying, if we get a path 26, yes, and then this is at 6.199. Why is it 6.199? Why is it not at 6? What? Okay, so as I was saying, what? Oh, because this isn't. What is going on here? Oh my god. What the heck? Okay. What's the difference from here to here to here is 0.197. That number again. 0.197. But that fuses it. And I don't want it to fuse. So I'm gonna actually move this down. Nope, crap. .197. Bam. Moves back. Bam. Now let's see it. Yes. 5, okay. So now we create a sketch. This is 26. So we go 6 here. From here, we go 6. And then we go 6 again. And then we go. And then we go. And then we go 6 again. So from 6 to 6, where's the points? So from here to here, right? Okay, so from here to here, I want to get the midpoint between this. And so from here to here, it's 3. So it's 3. So that's actually right here. So I'm going to put 2 here. Then from this is okay, so this is going to be another 6 from here, which I'll put the next screw over here. Yes, so this is pretty good because 6, 3, and 9 are the universal numbers, right? Except that this intersects with this, so it needs to be moved down more. So if we go back to this, instead of 6, why don't we make it 9? Oh, so instead of 6, we'll make it 8, so that it doesn't intersect. But then you would violate the 6, and 3, and 9. Make a 9. This is gonna hurt me to do this, but I have to extend this. Come on. No, what? Is this not equal? It is not. Okay, whatever. So we're gonna make it 1. Nope. That confuses it. I just want 1. What is going on? Okay. Let's get these out. 1. Why does it fuse even though they're apart? That's really weird. Let's get this out forward 1. Let's get the other one forward 1. Let's move it back. And then we will extrude these screws up. And we'll just make them open so you can actually know where they are from the top and bottom. Okay, look at that. Look how nice that looks. Nice and perfectly spaced apart, like they should be. Such as this. This is 9 and the other one is 9 as well. Okay, perfect. So the arc looks pretty good. Okay, so it looks like we actually have created a pretty good prototype for the first phalange. Yes, this is because this is the part of the metal carpal. It looks a little weird, cause oh, you know what it looks like? It looks like the snake from Python. Cause the yellow, like this is the eye, and like this is the Python snake, you know? Yeah. Okay. Anyways, it doesn't look like this is like the snake. This is eyes, and this is like the body. And like since the head is like curves up in the body, it's like yellow and blue. Okay. Crap. Let's think. Okay. That looks pretty good. And if we were to align the servos, this one will go, this was a 5 degree, right? This one, this is a, that has no rotation at all. This one should go a little bit up, but not farther than middle. This one should go just a little bit up, so it's like a pretty good arc. This one, because this one goes here. This one should go, I think it was a 10 degree. So, ooh, yeah. We can always have a rotation joint. Yeah, now we can have a rotation joint. This is a 5 degree. That kind of overlaps a little. I really like that. Here, right here, right here. This one. We could probably move this a little bit further up, right? A bit further up, and then we can get the other one to go a little bit down. Yeah, I mean, it looks pretty good. It's a little scattered. I don't really like that. Looks kind of weird, right? Since this is just a rigid bar joint, this would also have to be in the perfect alignment, which is kind of hard because if this has that. Okay, now we're thinking here. You know what? We could figure this out later, right? No, it's easier if we figure it out first. We figure that you figure this out. No, I don't want to figure it out. No, you. I have to. Why you have to? Because I wanna. Okay. If we do a bar joint, it would have to. If we do a double joint with a up and down and side to side, where it would move in any of these directions, we could actually connect it to this, right? And we could do. We could do a double joint for that actually. Since you would want it to stay, you wouldn't want to use like steel wire to hold it or something. So let's do a double joint on the servo horn so that it can connect to that. Because the connection doesn't really, no, but that would affect the strength. A double joint would affect the strength, right? And you wouldn't want it to be like a tendon or something, because then it wouldn't be able to go back. So for now we'll keep the. For now we'll get rid of the array. We'll keep the tendon rigid. So since we actually did make the mechanism already, we can work on the. What do you call it? We can work on the joint here, and then we can connect it. For this one, I would say we could use a double. I wonder if a double would be the best way, because that seems kind of weak, and I don't know how well the joints stay in place. If it were to be like a metal, basically a dowel, really. I pista. Okay, so let's get this here. Shibal. Okay, so let's get a view from front. So you want it to be equal, like that. That looks pretty good. Oh, but this one didn't move. Whatever. So I moved the 3. That's good. 3 is always good. 3 is a good number. 3, 6, and 9. But this is it's kind of weird, but that's okay. So it joins. This part seems like it would interfere. So I'm actually gonna get rid of this. I'm gonna do a construction. Move it up till this line. No, didn't move it up. Did you? No, you did. You did. It's good. Okay, so I'll move it up till this line. You do a construction here. And let's make it so that it goes from. It's just pretty big, right? And then looks like we have to do some mapping on this, but that's okay. This is so from here to here. It's 1. Okay, this is pretty good. And we just move this down. I'm gonna cut it down around, give or take, 2.5. Let's take a look here. This would be kind of up, so 2.5 is good. Let's do a cut down here. What the? Is this a paste? Is this the original? No, it's not. Is this the original? Extrude 15. It's kind of weird. Wait, what happens if I delete this? Oh, not good. If I delete this. Oh my god. Okay. So for situations like this, I'll show a pretty good life hack. So if you ever mess up and you have something like this, you just do this. You just select it. You just press V. Ta-da! Problem fixed. I actually don't know the side effects of doing this, but I don't think I don't think it's good. That's okay. Sometimes you just gotta. It's not good, but that's okay. -3. Yep. And let's do a -3 on here. Oh my god. No, I just meant 3. Nope, 3. Perfect. So, good joint. I'm gonna move this a little bit down. 6, down 6, yes. Look at that. Alright. -5, that's okay. Front view. Okay. What kind of joint do we want for this? A strong joint. That's what we want. Strong joint. I'll give you a strong joint from here. So, strong joint should be 4. Nah, it's kind of weak. But we'll make it out of metal. That's kind of strong. Which I don't know how I'm going to make it out of metal because I don't have any metal working stuff. But that's okay. That is okay. We persevere. We prevail. 6. 4. So you have 1 millimeter spaces in between. Perfect, perfect, perfect. Everything's going according to my plan. You go 1. Bam. We got 1. We got 1. Okay. We're gonna go from the middle of this, which is okay. So we have right here. What the heck? So I can see it, but I can't see it. What is that? Whatever. Let's just guesstimate right here. No. We got 1 on the top of this. Should be the 1. So 5. Oh, nope. It's actually 0.5 up. 0.25. From 0.25 we go 5. Yes. We want it to be 5? Yes, we do. Nope. We want it to be 6. Because it's actually, you can create a divot anywhere. That's okay. That's good. That's good. That's good. You want it to be larger because that means it's stronger. Let's edit this so we have a 2.5 in the middle. Yes, look at that diameter on that thing, man. That thing's gonna destroy you. 4. Oh crap. Oh my god. That's not in the correct. Bro, I did it wrong. Because this is supposed to be up. Because I put it in the wrong place. This is supposed to be up here. 2.5. Yes. And then we this extrude 4. Perfect. Okay. Let's move the bar out of the way for now. I wonder why I did that. I wonder why I did that. Oh, because I copied and pasted it, didn't I? Yes. Let's try this. Oh my god. What the heck? Oh my god. Oh my god. Okay, so I made a very big mistake because I didn't destroy the copy. So there's just like random copies of this thing floating around. So there's this. Yeah, buddy. Crap. Looks like I have to do this all over again. Because I didn't delete that copy. Which is why you should be deleting your copies. Yes, delete that. So now if I go back. It didn't work because there's the copies. The bar linkage is still there. Okay, crap. So if I go back to this timeline, I remember doing this, okay. So I'm actually gonna delete these. This was 1 step forward, but 6 steps back. But that's okay. Because progress means there's failures. And that was actually, I think, my first failure. No, this is my first failure. Okay, whatever. It wasn't. It was a success, actually. Because that means I get to do this over and over again. 35? Okay, let's actually make sure there's no more copies. That's good. Let's get this centered. 3. This magic number. Alright. Now for this, we get the bar linkage. We already kind of did this. You know what? Let's actually do this. Instead of doing that offset thing, why don't I just kind of, since this is already a pretty good plane, I could do this, and I can go from here. 3.2, and this is just 10, right? 0.5. Nope, it's not 10.5. From this point to this point, boom. Now I just extrude these two. These 3. Yes. Up 2. Now I go -1. 0.5. Or was it 2.5? -2.5. Nah, I think it was -2. Just 2. -1.5. Okay. And I remember I did this. Yeah, -3. And then this is +3. Alright. Remove that, delete. Perfect. Save that. Okay, now we go into the bar linkage thingy. Which We just did one offset. Create a sketch here. Okay, so it's actually from the middle of this. It's 0.25. Oh, actually 25. Control Y. Yes. Okay. So from here, the middle of this is actually 0.25. Which that disappeared? What? Why did that disappear? 0.25. There you go. And this was 5. No, you want it to be 6. And then you want this one to be 2.5. Okay. Now, we get the bar out of the way. Get out of here, bar. Yeah. You bar, you stupid bar. Actually, you're not stupid. Because I actually need you to hold the linkage. Alright, perfect. Yeah, it looks pretty good. Let's get the... This, I think this is kind of a little bit too big. You want this to be a little smaller, so we'll go -1 for that surface. And then this one, I remember I moved it down a little bit. -5, 6. That seems pretty good. I think this is the palm, this is the finger. For now, it's okay. Alright. Let's create a bar from here to here. Now, how will we do that? Interesting question. What insert should we use to keep these? Metal linkage insert. I hope that's good. A metal link. MLI. Oh, metal linkage insert. That's good. Are these not fused? What is going on here? This is overlapping. Oh my god. Is this the other one overlapping? It is. That's why the print was so hard to put in. Oh my god, I can't have this overlapping, man. What is the diameter of this? No, not the diameter. Not that. What the heck? Get the bearing. This is 7.70. Which is that the actual diameter? Yes, it is. It's 7.7. Okay. What about this? Is this 7.7? Yeah, it is 7.7. So why is it overlapping? That's pretty weird. I don't know what's going on with that. That's okay. Let's create a bar linkage. This is center point up here, 3. This is 3, so this is 6. So from 6, we're gonna go angle of 45 at 4. Nope, 4.5. Nope. Alright, just 45. Let's just do like 7, right? And the other one, you want it to intersection 45. Other one's like 8. 7, 8. Yes. So that's the intersecting points. From here, we're gonna go 2. So you want a total of 4. That's a little thin. I'm gonna be honest. I think that'd be better if it was 6. Yeah, so we're gonna go 3. Okay, so if I was gonna do it anyway, there's no point in doing this, but there was no point in doing all this. I could have just put a fucking rectangle, like, but that's okay. That is okay. Alright? That is okay. And let's get that at 6. And the other one will be, I don't know, 50. Like 60. Because it's always better to have more than to have less. Hey, that's pretty good. Let's get this and this. Oh my god. What am I selecting? Yeah, let's fuse this with this. Oh, look at that linkage, man. Oh my goodness. Okay, so it's 4. It's 6 high, 4 wide. And 60 millimeters long. The width is okay. That's honestly not bad considering the joint linkage. Let's move these servos out of the way. Get these servos out of here. Stupid servos. Look at you. You're blue. You look like Megamind. Why do you have a gray thing? That's the place? Okay, that's... Oh, wait. Yeah, yeah, of course, bro. That's the placeholder. That's not the placeholder. That's the servo. That's a servo holder. Why am I saying place? It is a place, but it's a placeholder servo holder. Okay. So I'll actually make a copy of this, just as a test, right? Oh, did I paste it? No, I didn't. Okay. And then yeah, no, I'll make a copy of this, and I'll make a copy of this, so that I can connect these, and I can get a good linker. Hold on, no, I don't want to do that because I haven't made the connection for the servo yet. So looking at it from the front, if we see this, I actually misjudged here because I thought the servo this was the whole thing, right? But it's actually not. The servo horn is a little thin, if I'm being honest. So let's measure this. This is a 2. So if we make it 1 more, so we get 3. Yes, 3. So this is how much is that? 6, and this is, what is it? Okay, hold on. This is at 10. From here to here is 1.5, and here to here is 4.5. So we move this to the right 1.5. Instead of doing that, I can actually just no 1.5, negative 1.5, so that you would have that aligned with this, right? Yes. Let's move that forward just to check. Oh, it's not aligned actually. That is not aligned. Find the equilibrium between these 2 points. What is this? Oh, they're not even fused. Okay, actually I'll fuse this so I can measure it. 0.395. 0.605. Okay, so 0.605 and this is 0.395. Okay. Now how will I move this? So let's see. It's gonna be 4. Okay. This is also, this is 3. So it's gonna be 0.5 from this to here. Got it. So I'm gonna move this, I want to move it from here, from that face, right? Move from here. Bam. Perfect. Okay. Now I'm gonna move it the other way. Negative 0.5. So now, if you look at it from the top, look at it from the top, it is aligned, right? Yes. Okay, so that's aligned. And let's get some linkages here. What could I use for linkage? I'm not sure. I kind of forgot to color this, so I'll actually make this black. But it doesn't look like anything, so let's get iron, because it wants to be iron. Yes. But it doesn't look like anything though. Oh man. Crap. How about we get plastic? EPX150 air baked with carbon M2 M3L1 3D printers. That sounds intimidating. It doesn't really look like anything. Okay. Let's get rid of that. Let's just make this green. Yeah. Cause this is the hubcap is green. This is a hubcap. What do you? I don't know. I don't know what it's called. Actually, I kind of forgot what it's called. I think it's called like axis cap or something. Okay. Oh, that's fine. That's fine. So let's get this. Wait, should this hand have air cooling? Oh, because if you use it a lot, this road's get hot, right? So you want to have air cooling. That's okay. We'll see that later. Let's just focus on the hand for now, right? Yes, we focus on the hand for now. Bar linkage. Okay. So if we actually look at this, how long is this? I think this is like 10. From that end to that end, 10, yes. Okay. So, go back. Why is this? I thought this was Chrome. What is going on here? Why does it look like that? No, I want this to be Chrome. Why is it? No, I don't want aluminum. No, okay. You know what? That's okay. I think that's okay. Wait, that's actually. Nah, that's okay. I like the green. The green looks good. It's like Minecraft. Okay. So you okay? Oh, I'm gonna do a fillet here. What? I'm gonna fillet this. What in the? Don't tell me this is a. Why is there a copy of this? Why is there a copy of this? Why is there a copy? Okay. So that's what was going on. That's what was wrong. That's why this wasn't turning Chrome. Ah, okay. Oh, I don't know where these random copies keep coming up from. Uh, still aligned. Good. Now, if we think of that as 10, if we have, let's just say 4 fingers. We would always have 6 fingers, but 4 primary fingers, excluding the thumb. So I have 105 millimeters of rod. So actually, let me see if I can find a little more. If I do, that'll be really, really good. somehow, by sheer luck, I do have axle rods. These are 2 axle rods for axle rods. So now, with 2 axle rods, I can create more linkages. And this one's even longer. No, that's not, it's the same length. Okay. Anyways, with 2 axle rods, I can create more linkages. Let's see here. 2 axle rods, I can create more linkages. 1 viewer. Holy crap. I actually have 1 viewer, man. That's crazy. Looks like I've been streaming for. Oh, whoa. I can't be showing that. No. That's my stream settings. Okay, crap. So this is like that, and why don't we just create a bar? Start from here. Right? Nope. Yeah, no, that's actually good. So if let's do 6, 4 by 6. Yes. Let's just expand this to be, I don't know. This can be 6 by 3. Yep. And the other one can also be 6 by 3. So we will now push that down till it's here. Good. Okay, so now we'll create an axle here. We'll create an axle. Let's do a center point for this. 45. No, what? Why did it create an arc there? That's so weird. 45 and 8. Perfect. On the other side, it's going to be 45 and 8. Good. From here, I will go and create 6. You know what? Make it 9. That is good. 9. Okay. So now I'll go from the top. I'm gonna cut this part out since that is 4. I want to find 10, so I'm gonna go for 5. That's the middle point. 2. Nope. Make it 3 because you still have that 1 millimeter of extra space, right? Make the other side 3. Make this 3. Yep, that's good. And then, oh crap. Make this a solid. Push that down. I'll push these up a little bit. Let's make this up by 3. This, nope, go back. This one. This is 2.5 for linkage. Not linkage. Axle. Yes. 2. Okay. And let's get the other side. Right here. This is 45. What the? No. 9. Yeah. So somehow that was like negative 45, which is weird. Sure this is 45? Sure don't look like it. This is 45. I don't know, the other one is 45. Right here. this is like 145, huh? Nope. This is 135. There you go. 2.5. And then you go to 9. Good. Alright, so from 9 to 2.5, we're going to extrude this until it's here. Bam. Now you have a bar linkage, which I'm going to go to here. Find the midpoint of the circle. I'm going to go to 2.5. Bam. And then I'm just going to destroy that. Yeah. It's not cut, it's destroy. Perfect. Now let's create a copy of these two, which I'll use in my test base. Yeah, and make sure there's no extra copy like there was last few times. That's good. Alright. So for my testing apparatus, I'm gonna take this. I'm gonna move it so that these line up. Perfect. Move it from the... No, I don't have to move from the top. Alright. That looks pretty good. Looks good. Let's get a rod. Control C. Control V. Oh, crap. Did I? I didn't copy that. Let's, I can't do that. What the heck? Control C. And Control V. Let's get it. I thought I moved it. Wait, what? I think I deleted the wrong move. Okay. That's okay. We'll put that here. And then we will get this. Move that. Up. Bam. Now we have a bar linkage system. Except that the bar might slide out. So I'm actually gonna create some I'm gonna create a proof for that because I don't want it to slide out. Since you wouldn't, I feel like when it moves, it probably, the bars would tend to do that, right? Unless it doesn't, which that's pretty good if it doesn't. So let's why don't we do this? Why don't we just put caps on these? Yeah, that's what we'll do. We'll just put caps on these, right? Yes. Yes. One. Know what? No, I don't want that to move. Is that it? No, it's a little bit down. Okay, why don't we do this? I create a sketch. This is on the same plane as that, okay? You know what? I'll just create a sketch here and I'll make it a separate body. And this can be yep, that's good. And I move this as new body. Yeah. Not join. Okay, so 2. Yep. That's good. The other side. Call these caps. Alright. So it's gonna be the servo axle cap. So put that there. Bam. Oh, that already selected it. Whoa, oh my god, what the heck? Jeez, what just happened? 2. New body. Bam. Let's get a screw placement 2. Nah, I feel like the smaller screws. I'll use a smaller screw. So I'll use 1.5. I'll use 1. 1 is good. So just 1. Nope. I want to find midpoint of this. Yeah, I don't want it to be like that. Okay, that's good. Do 1.5. There you go. Alright. Now just extrude that. Bam. Oh, now that is looking good. Now that's like a real phalangeal joint type thing. Which that looks good. And then I'll join these, right? Yeah, make this a pretty good testing apparatus. So when this moves up, it should also move. Now I should probably be doing joints, making these components and then creating a joint on them so I can actually simulate it. So I'll do that later. It's pretty late. I think I should be going to bed, man. Alright. Well, thank you for watching my stream. I'll continue modeling next time. So yeah. Be on the lookout for version 3. Because the version 3 hand, you know, I actually used to call it the Omni hand until I realized there was also another company. They created something called the Omni hand, and then I was like, wait, but I came up with it first, but I never really actually called it the Omni hand. I've always been just calling it the V2 robotic hand. Oh, and also to the guy who in my YouTube video said Perry. Thank you so much, dude. I love Ultra Kill. Ultra Kill, oh, so good. Okay. Yeah. Thank you for watching my stream.